A light year sounds simple, but it hides a huge distance that challenges human understanding. How long would it actually take us to travel that far? Truthfully, it will take a longer time. With the current technology, traveling a distance of 1 light year would take thousands of days, or even centuries. In some cases, it could even take tens of thousands of years to reach that far. That means many generations of people would live and die before the journey could ever be completed. A light year may seem simple, but it's not. It is a measure of reasonable distance, not time, and also a representation of how far light can travel in 1 year. Scientifically, it's been reported that light travels faster than any other object in the universe. Since our fastest spacecraft travels slower than light, achieving that same distance would take a longer time. This reveals how broad and overwhelming the universe truly is. Even reaching the nearest stars is far beyond our current abilities, notwithstanding that humans have traveled to the moon and also sent robots to other planets. To make this make sense, we need to understand why traveling 1 light year would take that long. Firstly, we need to clearly understand what a light year actually means. Even though any credible reader may assume the word year means time, a light year is not about time at all. It is a unit used to measure distance. A light year is the total distance that light travels in 1 full year while moving at its constant speed through empty space. Light moves extremely fast. It usually covers about 300,000 kilometers per second, which is about 186,000 miles per second, at a great speed, which is almost impossible to imagine. In 1 second, light can go around the Earth more than 7 times. Then in a minute, it travels about 18 million kilometers. In an hour, it covers more than 1 billion kilometers. When you add that speed up for an entire year, the distance becomes about 9.46 trillion kilometers, which is equivalent to 5.88 trillion miles. That huge number is what we call 1 light year. These numbers are so big that they are hard for the human mind to picture or even calculate. We usually think or calculate distances between towns, cities, and countries too, which are very easy to figure out. Speaking of trillions of kilometers, it's a distance our brains can't even rally around. It's beyond human imagination. For example, if you drove a car at 100 kilometers per hour without ever stopping, it would take more than 10 million years to travel 1 light year. Even a fast aeroplane flying non-stop would still need over 1 million years. This gives a clearer understanding and also reveals how broad a light year truly is. Now, comparing human-made spacecraft to the huge distances in space, this was proven with one of the most famous spacecraft, Voyager 1, a deep space probe sent out by NASA in 1977. The major purpose for which this spacecraft was designed is to explore the giant planets like Jupiter and Saturn. After completing that mission, instead of stopping, it continued moving outward, heading toward the vast emptiness of deep space. Years later, it was reported that Voyager 1 holds the record as the farthest human-made object that traveled from Earth. It moves at a speed of about 61,000 kilometers per hour, which seems incredibly fast. On Earth, that speed would let you travel across continents in minutes, even faster than any plane. But in space travel, it is slow. Space distances are so huge that even this speed can't be compared at all. Nearly 50 years of traveling, Voyager 1 has reached a distance that is roughly equal to 1 light day from Earth. A light day is the distance that light can travel in a single day. Since a light year contains 365 light days, Voyager 1 has only covered about 1/365th of a light year. In other words, after half a century of movement, it has only covered a little fraction of the distance between stars. However, comparing Voyager 1's speed in terms of time, it would take roughly 17,000 to 18,000 years to travel 1 full light year. To understand better, think of human history. Around 18,000 years ago, humans were living during the last ice age. People didn't have cities, writing systems, or advanced tools like now. If someone from that time had launched Voyager 1, probably it would only cover a distance of 1 light year from Earth. Even after all that time, it wouldn't even come close to another star. The closest star to our Sun is Proxima Centauri, which is about 4.24 light years away, which means even light that travels at a faster speed of 300,000 km each second could possibly take more than 5 years to travel from a star to the Earth. So for Voyager 1 to reach Proxima Centauri would take roughly 74,000 years, which is even longer than most of recorded human history. History recorded that modern humans have existed for 200 to 300,000 years, which means such a mission would take a major portion of our entire human timeline. From speculation, Voyager 1 is seen as the fastest human-made spacecraft ever built. But there's another faster spacecraft, Parker Solar Probe. It was launched to study the Sun closely. This probe covers about 635,000 kilometers each time it swings around the Sun in its orbit. The probe is 10 times faster than Voyager 1. With its incredible speed, traveling 1 light-year would definitely take fewer years. That is a huge improvement compared to 18,000 years, but will still cost an entire human lifetime. Escaping our solar system is also not as simple as it is. In 2012, Voyager 1 was able to cross the heliopause, a boundary where the solar wind from the Sun gives way to the plasma and particles of interstellar space. This milestone was massively celebrated worldwide. But the Sun's influence goes beyond that. The solar system is covered by a large, rough spherical region, the Oort cloud. It is made up of tiny icy objects and comets. Most scientists think the Oort cloud may even cover up to 1 or 2 light-years from the Sun. This means that even after traveling 1 light-year, a spacecraft could still be within the outermost edges of the Sun's gravitational influence. In other words, leaving the solar system is completely more complicated than crossing the orbits of the planets. It takes so much courage to travel across such a huge distance. Could future technology change this? Scientists have proposed advanced engines powered by nuclear fusion. Of course, this could push a spacecraft to at least 10% of light speed, about 30,000 kilometers each second. At this particular speed, a ship can possibly travel a light year in 10 years and also 42 years to reach Proxima Centauri. But the challenging thing is, to achieve this spacecraft would consume a huge amount of fuel, which is really difficult and can't be handled with current technology. Secondly, creating, controlling, and monitoring these engines safely without any harm is quite difficult and beyond our current abilities. Another crucial reason is the inability to handle the space dust. These dust particles are usually harmful and would likely strike with force or even explode once hit because of the speed covered by the spacecraft. Therefore, protecting the spacecraft from all of it will be extremely hard. Another thing that affects this is the human factor. For example, if hundreds of individuals embark on space travel, barely one person would survive the entire trip, except they use a generation ship, a huge spaceship where they could live for years to protect themselves. But how can one possibly remain sane with this idea? Confining a stable society in a sealed metal vessel for a long period would be very challenging. Many social structures could be destroyed because of this. However, it needs huge resources and is very expensive too. Also, cultural changes may even affect the original plan, and other generations may not be interested in this because it's very risky. Another challenge limiting space travel is the physical barrier. According to the groundbreaking theory propounded by the great intellect Albert Einstein, the universe behaves in ways that continue to astonish scientists today. In the theory of relativity, he stated that nothing that weighs or occupies space can travel faster than the speed of light. Its mass increases effectively and needs more to keep accelerating. So to reach the speed of light, it requires an unending energy, which is hardly possible. It makes light speed the universal speed limit. Some scientists have explored mind-blowing ideas such as warp drive to enhance spacecraft to travel conveniently but not through the usual way. It's done either by bending or folding space-time itself. This is really fascinating. This theory may not be the best, and there's no scientific experiment to support it, but the future of space travel would be secure if humans figured out how to manipulate space-time. Trying to comprehend even a single light-year forces us to confront the mind-blowing vastness of the universe. The stars that appear close together in the night sky are in reality separated by immense stretches of almost empty space. Our entire solar system, a collection of planets, moons, and asteroids, fits into a tiny corner compared to the distance between neighboring stars. Traveling even 1 light-year, the distance light covers in a single year, shows just how enormous the gaps between stars truly are. At this stage in human history, we are still at the very beginning of exploring space. We have successfully landed robotic explorers on Mars, sent probes past the outer planets, and even reached beyond the heliosphere, the edge of the Sun's influence. Yet we have not sent humans past the Moon since the Apollo missions, and interstellar travel, the kind that would take us to another star system, remains a dream for the distant future. For now, the numbers are sobering. Voyager 1, our fastest spacecraft to leave the solar system, would take nearly 18,000 years to travel a single light year. Even the Parker Solar Probe, the fastest human-made object relative to the Sun, would require over 1,000 years. 1 light year is not just a number, it is a measure of the immense challenge of reaching the stars. It reminds us that Earth is rare, precious, and for now, our only true home. Will a 1 light-year mission still be impossible? Drop your thoughts in the comments section. Also feel free to subscribe to this channel for more thrilling stories on tech. Bye for now.